Upgrading an electrical service using parallel feeders within existing conduits is possible, but several critical factors must be considered to ensure a safe and code-compliant installation. This involves several steps and adherence to electrical codes such as the National Electrical Code or NEC. Firstly, assess the conduit size and configuration. The existing 4-inch conduits must be adequately sized to accommodate the parallel feeders. In this scenario, we're discussing two sets of 400 mcm copper conductors per conduit. Ensure the conduits run parallel to each other, ideally within the same trench or duct bank. Sufficient slack should be available to facilitate the pulling process. Secondly, consider the feeder size and type. Each set of parallel feeders will consist of 400 mcm copper conductors, as mentioned before, with 4 conductors per conduit. The insulation of these feeders must be appropriately rated for the voltage and temperature conditions specific to the installation environment. Ensure that the selected conductors meet or exceed the required ampacity for the upgraded service. Next, employ proper pulling methods. Utilizing a pulling lubricant or compound is essential to minimize friction during the pulling operation. It is recommended to pull the feeders one conduit at a time, securing them at both the entrance and exit points of each conduit. Secure anchoring of the feeders at each termination point is critical to prevent any movement or strain on the connections. Then address electrical considerations. Calculation of the ampacity of the parallel feeders must be performed to verify that it meets or exceeds the load requirements. Confirm that the existing transformer has the capacity to provide the necessary kilovolt amps or kVA and current for the upgraded parallel feeders. A suitable main lug or breaker panel should be installed at the building entrance to facilitate the connection of the parallel feeders. This panel must be rated appropriately for the increased amperage. Afterwards, ensure code compliance. The entire installation must fully comply with all applicable electrical codes and standards, with a primary focus on the National Electrical Code and any other relevant local regulations. Obtain all necessary permits and inspections from the local authorities to ensure that the installation meets all regulatory requirements. Several additional notes should be considered. Firstly, utilizing proper pulling techniques and appropriate equipment is essential to prevent any potential damage to the feeders or conduits during the installation process. Secondly, consider implementing phasing tape or other identification methods to clearly distinguish the different phases of the parallel feeders. Thirdly, install a comprehensive grounding electrode system and ensure all bonding connections are made in strict accordance with code requirements. These elements are critical for maintaining electrical safety and minimizing the risk of ground faults. When paralleling conductors, it's essential to adhere to NEC section 310.10. This section outlines the requirements for paralleling conductors. All conductors must be the same length conductor material, same size and circular mill area, same insulation type, and be terminated in the same manner. If all these conditions are not met, circulating currents could flow in the conductors and overheat the insulation. When determining the ampacity of the 400 mcm copper conductors, refer to NEC Table 310.16. This table provides ampacity values for various conductor sizes and insulation types, based on specific temperature ratings and installation conditions. The table shows the allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius, not more than 3 current-carrying conductors in raceway, cable or earth directly buried, based on ambient air temperature of 30 degrees Celsius. The ampacity will depend on the temperature rating of the conductor. For example, if using a conductor with a 75 degrees Celsius rating, the ampacity of a 400 mcm copper conductor is 335 amps. Since there are 400 mcm conductors per phase, the total ampacity per phase is 4 times 335 amps, equaling 1340 amps. However, you can only use this total ampacity if you adjust the values in 310.15 for ambient temperature and number of conductors in a raceway. NEC section 310.13b3 requires adjustment factors when there are more than 3 current-carrying conductors in a raceway or cable. If the number of current-carrying conductors in a raceway is between 4 and 6, the ampacity must be reduced to 80% of the value in Table 310.16. In this scenario, there are 6 current-carrying conductors in each conduit, so the ampacity of each conductor must be reduced to 80%. Therefore, the adjusted ampacity of each 400 nCm conductor is 335 amps times 0.8, which equals 268 amps. The total ampacity per phase for the 4 parallel conductors is 4 times 268 amps, equaling 1072 amps. This is less than the desired 1200 amps. To achieve the required 1200 amp service, you would need to use a larger conductor size or explore other methods of increasing the ampacity, such as using higher temperature rated conductors. Another method would be to use more than 2 conduits. If there were 3 conduits, there would be 2 current-carrying conductors in each conduit, so no adjustment would be required and the total ampacity would be 1340 amps. Also, NEC Section 250.24c discusses grounding requirements for separately derived systems. Since the service is fed from a transformer, it is considered a separately derived system and must adhere to the grounding requirements outlined in this section. A grounding electrode conductor must be connected from the transformer neutral point to a grounding electrode system, such as a ground rod, ground ring, or metal water pipe. The size of the grounding electrode conductor is based on the size of the service entrance conductors, as specified in NEC Table 250.66. Bonding jumpers are required to bond the transformer enclosure, metal raceways, and other non-current carrying metal parts to the grounding electrode system. This ensures a low impedance path for fault current to return to the source, facilitating the operation of overcurrent protective devices. Proper bonding is crucial for safety and equipment protection. In addition, NEC Section 250.102c outlines the requirements for sizing the grounded conductor for a grounded system. The grounded conductor must be sized to carry the maximum unbalanced load, as determined by NEC Section 220.61. It must not be smaller than the sizes specified in NEC Table 250.102 current. If the ungrounded conductors are paralleled in 2 or more raceways or cables, the equipment grounding conductor must be installed in parallel in each raceway or cable. Each equipment grounding conductor must be sized based on the overcurrent protective device within grounded conductors in the raceway or cable, as specified in NEC Table 250.122. When conductors are installed in parallel, it is crucial to ensure that all connections are made properly and are torqued to the manufacturer's specifications. Loose or improperly torqued connections can lead to increased resistance, overheating, and potential fire hazards. Regular inspections and maintenance of the connections are recommended to ensure their integrity over time. For safety, always to energize the existing service before starting any work on the electrical system. Use appropriate personal protective equipment such as gloves, safety glasses, and insulated tools. If you are not qualified to perform electrical work, consult a licensed electrician. Working with electricity can be dangerous and should only be performed by those with the proper training and experience. Remember, adherence to these guidelines, along with careful planning and execution, is essential for a successful and safe upgrade of the electrical service using paralleled feeders in existing conduits. Always consult the latest edition of the National Electrical Code and local regulations for the most up-to-date requirements. Finally, always prioritize safety throughout the entire process.